Hello, my name is Rashid Ansiri and I am a doctor engineer and a technologist in mechanical engineering, and I will try in this video to technologically introduce the coated electrode used in the SMAW process, of course as simply and as clearly as possible. Okay, let's go. First of all, it should be remembered that the SMAW means the Shielded Metal Arc Welding, and it is the most basic and the most used type of welding in industrial applications. Now, in this figure, you can see the electrode mounted in the arc welding station, and in fact it's not a simple electrode, it's a coated electrode. What does it mean, a coated electrode? It's an electrode covered by a coating. The electrode will lead the electric current and produce the electric arc between the tip of the electrode and the workpiece, and the intense heat necessary for the welding will be produced, and the coating will have some important roles during the welding operation. And it's to note that depending on the chemical composition of the coating, we will have different types of coating. Now I will talk about the roles of coating, and it's to note here that there are three principal types of roles: metallurgical role, electrical role, and mechanical role. For the metallurgical role, we talk about the protection of the molten weld pool against the oxygen and the nitrogen from the ambient air. In fact, this oxygen and this nitrogen are very harmful to the molten weld, and as you can see in this figure, during the welding, when the coating will melt, it will generate a superficial protective layer called slag that will protect the molten weld against the oxygen and the nitrogen from the ambient air. Now for the electrical role, the coating will facilitate the strike, in other terms the ignition of the electric arc, and it will help to maintain the stability of the electric arc. And as you can see in this figure, during the welding, when the coating will melt, it will generate or it will deposit ions in the air gap between the tip of the electrode and the workpiece. So this air gap will be ionized, and the electric arc will pass easily through this air gap. So in this way the strike will be facilitated, and the electric arc will be easily maintained. Now for the mechanical role, it's to note that there is three principal mechanical roles. The first one is the channeling and the concentration of the electric arc. In fact, as you can see in this figure, during the weld, the coating melts more slowly than the electrode, which generate this kind of channel, and the electric arc will be channeled within the inner walls of the coating, and in this way it will be concentrated. And the second mechanical role is about the improvement of the mechanical properties of the weld bead. In fact, as you can see in this figure, during the welding, when the coating melts, it will deposit chemical elements into the weld, into the molten weld, and these chemical elements will improve the mechanical properties of the weld bead. Now I will talk about the types of coating, and it's to note here that there are four principal types of coating: basic coating, rutile coating, cellulosic coating, and acid coating. For the basic coating, it is characterized by a high proportion of calcium carbonate and fluoride, and it will produce during welding a limestone slag. This limestone slag has a desulfurized effect, which is favorable for the welding of ferritic steels, and this desulfurized effect will reduce the risk of hot cracking of deposit weld. And it's to note that when we use a basic coated electrode in welding, it's recommended that we use a direct current with reverse polarity, and it's also recommended to carry out steaming of these basic coated electrode at 350 degrees Celsius for 2 hours. Now for the rutile coating, it is characterized by a high proportion of titanium dioxide, and it will produce during welding a slag easily eliminated, and it will permit welding in all positions, and also it will permit a good mechanical characteristic for the deposit weld in the case where the steels have limited carbon and sulfur contents. And it's to note that when we use a rutile coated electrode in welding, we can work with a direct current or an alternating current, and there are no special precautions to take into consideration for the rutile coated electrode. Now for the cellulosic coating, it's characterized by a high proportion of cellulose, and it will produce during welding a little slag, and it will permit a rapid welding in downward positions. Also, it's to note that the cellulosic coating will permit an improved penetration, and we should take into consideration that when we weld using a cellulosic coating, it is recommended to use a direct current with a reverse polarity. Now and it's recommended also to use an open circuit voltage higher than 60 volts when we weld with a cellulosic coated electrode. Now for the acid coating, it's characterized by a high proportion of acidic matter, and it will produce during welding a slag which is fluid and abundant, and this acid coating will permit a flat and horizontal welding positions, but no vertical and overhead welding positions. Also, it's to note that the acid coating needs a base metal with good weldability, and there are no special precautions to take into consideration when we weld with acid coated electrode. Now I will talk about the electrode classification, in other terms the electrode designation, and as it is suggested by the American Welding Society, the electrode designation is based on the prefix E followed by 4 digits and sometimes 5 digits. The prefix E means that the electrode is used in arc welding. The 2 next digits and sometimes 3 digits means that represents the minimum tensile strength of the electrode in 1000 psi. It should be remembered here that 1000 psi is equal to 6.89 megapascal, and the next digit represents the weld position. It will take the value 1 when the electrode can be used in all welding positions, and it will take the value 2 when the electrode can be used only for flat and horizontal welding positions, and it will take the value 4 when the electrode can be used in flat, horizontal, vertical down and overhead welding positions. And this digit associated to the last digit will represent the type of the coating and the current and the polarity based on, for example, this table. Now, for example, this designation E6010 means that this is an electrode for arc welding. 60 means that the minimum tensile strength of this electrode is 60,000 psi. 1 means that this electrode can be used in all welding positions, and 10 means that the type of the coating is the high cellulose sodium, and the welding current is DC+, which means direct current reverse polarity. Another example, E118 E means that this is an electrode used in arc welding. 100 means that the minimum tensile strength of this electrode is in the order of 100,000 psi. 1 means that this electrode can be used in all welding positions. And 18 means that the type of the coating is the iron powder low hydrogen, as it is indicated by the table, and the welding current is AC or DC plus. AC means alternating current, and DC plus means direct current with reverse polarity. I will appreciate and answer all your questions, your remarks, your suggestions in the comments. Thanks a lot for your attention.